Okay, that lesson on proofs was a lot of fun. Let's get now into more about parallel lines. We'll talk about what's known as a transversal. I'll tell you more about that later, but it's going to kind of deal with kind of what would look like this parking lot of lines here. Got the parallel lines with the spaces, and this line would be known as the transversal, whereas these are the parallel lines. So we'll talk about more of what that means and what happens with the angle pairs that are formed by all of those lines in just a little bit. First of all, though, let's talk about parallel lines and what that means. So two lines that do not intersect or do not cross are known as either parallel lines or skew lines. If they're in the same plane, they're parallel. If they're not in the same plane, if they're not coplanar, they're skew lines. And two planes that would never intersect would be known as parallel planes. So lines M and N are parallel lines. And the symbol we use is two up and down line segments be the symbol for parallel. Lines M and K are skew. Planes T and planes U are parallel planes, so T would be parallel to U. Lines K and line N are intersecting lines since they cross this point. There's a plane containing them, be kind of a vertical plane. It's not shown. So the small directed triangles is shown on lines M and N. Those little red symbols there, that shows in a diagram that lines are parallel. Sometimes instead of a triangle, it might just be kind of like an arrow there. It's not a full complete triangle. It'll just mean parallel, and this symbol also means is parallel to as well. Segments or rays are parallel if they lie within the parallel lines. A line is parallel to a plane if the line's in the plane parallel to the given plane. So line N would be parallel to plane U in this case. Okay, so that's our definitions of parallel. So assumption, you can't assume that lines A, B, C, and D are all parallel. Remember we talked about never assume. You need the diagram to tell you. So only line A would be parallel to line C because they have those arrows on there. Which lines are perpendicular down here? Correct. None of these are. There's nothing in the diagram to indicate that they're parallel. It's like parallel lines need these arrows. Perpendicular need the right angle box to show that those are 90 degrees. Okay, but since it doesn't have that in there, we'd say that none of those lines are perpendicular. Okay, so always trust the diagram. It's got to be indicated in the diagram that it is. Take a look at these segments in the figure here. Lines parallel to CD and containing point A. The only one parallel, well, that would be line BA, segment BA. None of the other lines would be parallel. Give me a line skew to CD. So maybe you just want to pause these and see if you can answer them. According to the diagram, restart it when you're ready. All right, so hopefully you had a chance to try that line skew to CD and be line AH. It's in a different plane. It's never going to cross. Also, line segment GA would never cross as well. If you can find others, sure to let me know if I made a mistake. But BA would only be parallel, only parallel one. Line perpendicular to CD. According to the diagram, we've got this line AD here, or DA, as I wrote it. And then plane parallel to plane EFG would be this plane on top, plane ABC, or maybe you wrote it a different way. But that's the only one containing point A. All right, so parallel postulate. If there's a line and a point not on the line, then there's exactly one line through the point parallel to that given line. There's only one line that we can have parallel through a certain point. If there's a line and a point not on the line, then there's exactly one line through the point perpendicular to the given line. So if I've got line L here, there's only one line that can go through point P and be perpendicular. So let's take a look here. Identify according to the markings. Be sure you can't assume. So look at the markings on the diagram and identify parallel lines, perpendicular lines. So a pair of parallel lines. Well, I've got two arrows here for line DM, and I've got another two arrows indicated there to show that EF is parallel to DM. Perpendicular lines in the diagram, I've got this square in the corner, so that's line AM, and the perpendicular marking is an upside down T, and that'd be perpendicular to line BM. So is FE parallel to AC? FE and AC. Well, you can clearly see that they're going to cross at some point, and there's no arrows on there, so no, it's not parallel. Are you kidding? Okay, so next we're going to take a look at an activity, and you're going to figure out what these terms are: corresponding angles, alternate interior angles, alternate exterior, same side interior. And from that, we're going to learn some properties with those angles. So here's two lines and a transversal. Okay, and the same here, we have two parallel lines and a transversal. So we'll talk about properties once we know that the lines are parallel. I told you we're going to tell you what a transversal was. Well, that's your job. Which one do you think is the transversal? Line P, line Q, or line R? Well, it's line P. Line P is the transversal. Trans means across, so it's lying across two different lines. So that's the definition of a transversal, a line that goes across two other lines. And maybe a better, more technical definition would be transversal is a line that intersects two, and it could be more lines. In this case, it just has two as the basic form. But it's two or more coplanar lines. It intersects them in more than one place. So here we've got line Q and line R being intersected those two places as our transversal. So line P, you can write on your notes there, is the transversal. Okay. Now, what do you think is created when two lines are intersected by a transversal? You can kind of see it on the diagram, but I've got different angles that are formed. Okay, and that's the connection we're going to try to look at as we're looking at lines and angles and the connections that they form. So directions say put two post-its. Well, if you don't want to put post-its, just point at on your diagram. Which ones are corresponding angles? What do you think are corresponding angles? Just based off of that term, corresponding. Well, corresponding angles are ones that kind of match up in the same spot. So this transversal cuts through, and we have the two lines, lines Q and lines R. And as we look at those lines, we've kind of got the same quadrants there. So angle 1 and angle 5 are both upper left. So 1 and 5. And we have a couple angles that are upper right, 2 and 6. And we also have 4 and 8. Kind of looking at those are below. And the other corresponding angles would be angles 3 and angle 7. Okay, so that's the corresponding angles. So as you think of corresponding angles, you can remember them as being in corresponding positions in regards to the transversal line. Okay, interior angles. Which ones do you think are interior angles? Well, maybe you guessed these ones. Hopefully. If not, well, you were wrong, but that's okay. At least you tried, right? So interior angles are the ones between these two lines that are crossed by the transversal. They're just between them. Okay, so if we're talking about same side interior, well, if this is the transversal and here are the interiors, which ones are on the same side? Hey, how about 3 and 6? Hey, what about 4 and 5? Yep, you're right. So same side interior, we could say angle 4 and angle 5. And we could also say angle 3 and angle 6. They're also referred to as consecutive interior angles. So if you ever see that term, it just means the same thing. Consecutive is just a fancier word. It means the same thing as same side. So consecutive interior angles or same side interior angles. Alternate interior angles. Well, same thing. If we've got transversal and these are the interior angles, these ones alternate sides. So let's say angle 4 and angle 6, angle 3 and angle 5. Okay, hopefully that's starting to make some sense. So let's get now to the exterior angles. By now, hopefully you figured those out. Here's our transversal line, and these were the interiors, so it can't be those. These are just the only ones outside. Exterior means out of, or outside. So 1, 2, 8, and 7 will be the exterior. So alternating exterior angles. As we're looking outside, well, they cross sides of the transversal line. So 1 and 7, 2 and 8. So angle 1 and angle 7, angle 2 and angle 8. Okay. So hopefully we figured out what these terms mean. So anytime we have a transversal, we can refer to the angle types on those 4 basic types corresponding. Same corresponding position, alternate interior, alternating between the 2 lines, alternate exterior, alternating sides of the transversal outside of the 2 lines, and same side or consecutive interior. Okay, so now we're going to take a look at parallel line conjectures. If those 2 lines are parallel, we have a transversal cutting through them, what do we think is true when we have those types of angles? So here's the scenario. We've got parallel lines and this transversal cutting through it. Just ponder on that for a moment. What do you think is true about these corresponding angles, like angle 1 and 5? What do you think would be true about those angles? What do you think would be true about alternate interior angles, like angles 3 and 5? How about the alternate exterior, like 1 and let's say this is angle 7? What do you think is true about those? Well, corresponding, it appears, what do you think? They look congruent, don't they? How about 3 and 5? Don't those look about the same? 1 and 7? Those look congruent too, don't they? And then same side interior, that would be like angle 4 and angle 5. Those don't look the same. What do you think is true about those? So let's take a look and explore that for a second on GeoGebra. Oops, see if I can get there. All right, so here's our parallel lines cut by a transversal. So let's zoom in here. If we have vertical lines, we know those vertical angles are congruent. We've already talked about that before. Let's look at a set of corresponding ones. Yep, it's true that those are congruent. Even if I change the angles, those always stay the same. Alternate interior, as we thought before, those are congruent. Yes, the angle stays the same no matter how I move those. Alternate exterior, those remain congruent. And the consecutive interior, also known as same side interior, what's true of those? They're not congruent, but we have, this one's about 120, this one's about 60 when we round them. So 120 and 60 is 180. Those are supplementary no matter what I do to those angles. 111 and 71, so it always remains supplementary. And we'll talk about why that happens in a moment, but that's something that you'll want to write down into your notes, is that corresponding angles are congruent. Oops, there we go. And exterior angles are congruent. Alternate exterior angles are congruent. Same side interior angles are supplementary. So that will always be true when you have parallel lines. In this case, these lines are in parallel, so we don't have those same relationships there. Now the question is, how many different angle measures do we have when parallel lines are cut by a transversal? So let's just imagine that for a second. And let's say we have these angle measurements here. And let's just pretend now that we've got a measurement of, let's say this one is 60 degrees. Vertical angles are congruent, so these are 60. If I translate these angles down here, these would have to be 60 as well, also because they're corresponding. This one's 60. These are a linear pair, so this has to be 120. Vertical angle is 120. And same side interior, supplementary. And then we've got vertical angles again. So we only have really two different angle measurements when lines are parallel. You can see that line A, I could just translate that down to line B. And notice everything stays the same. So that's kind of cool. Everything is only two different angle measures you got to figure out, and you can figure all the rest of them out. So just a brief review here. Pairs of angles corresponding. Notice which one's a transversal. This one's intersecting two different lines. So 1 and 5 corresponding, 2 and 6, 3 and 7, 4 and 8. Alternate interior, 2, 7, 4, 5. Alternate exterior, 1, 8, and 6, 3. Consecutive interior, 2, 5, and 4, 7. Okay, so the lines don't have to be going horizontally. They can be going vertically as well. Congruent angle. So let's see, we talked about this before, but if this is 120, vertical angle is 120 here, which means these are 60 because they're linear pair, and we would translate those ones over. So 120 here. This one's also 60, 120, and 60. So if we just know one of the angles, if we know that the lines are parallel, we can figure out all the other angle measures. So let's apply some properties now. First of all, I want to find x. So what do I know? Well, this is angle 4, so I don't know much about that. It really doesn't help us at all. It doesn't give us a measurement. But I know these two angles. What's true about these two angles? Are they one of those special angle terms that we talked about? No. Let's just start taking what we know. Well, if this is 115, this one's 115 because they're vertical. If that one's 115, this would have to be 65 degrees because they're a linear pair. 65 degrees. And then I could translate it all down. This one would be 115 because it's corresponding with this one. This one's 115. Here we have 65 and 65. So I know that angle x plus 5 has to be the same as 65. Gives me an equation to solve, so I subtract 5, and I know x has to be 60 to make that true. Just apply what you know about those angle pairs, and you can set yourself up an equation. Now, the moment you've all been waiting for. Why? Why is this true? Why is it always true? If I have two parallel lines cut by a transversal, how do I know that angles 1 and 2, the alternate interior angles, will be congruent? Well, let's just write down what we know. P and Q are parallel. It's our given information. Okay, I know 1 and 3 are corresponding angles, so they have to be congruent. Okay, so if I know 1 and 3 are congruent, well, I have angle 3 here. What do I know is true about angle 3 and 2? Well, 3 and 2 are congruent because they're vertical angles. Vertical angles are congruent. Well, I know 1 is congruent to 3, 3 is congruent to 2. Therefore, by transitive property, 1 is congruent to 2. So that proves that alternate interior angles will always be congruent. So that brings us to the end of our lesson today. Hopefully you learned about what a transversal is and what the different angle pairs are, and especially what happens when we have parallel lines, what is true about these different types of angle pairs. So if you have any questions, we can talk about it in class. Otherwise, we'll see you next time.